Alrighty, so we are going to work through the Precalculus 6-5 assignment. So here's the assignment and page number that we are working through. I do have a copy of the text here, which is what we will be working with. The first problem here is number 1. And so if we look at number 1, it's saying that you need to complete the table and then plot the corresponding points. So basically you just need to take this theta and plug in each of these values and see what you get for r, and then we'll plot them. So we'll take the time to recreate the table. And the table is for the formula 3 cosine of 2 theta. This is a rose curve. So it's going to have some sort of shape kind of like this because it's got a cosine and theta. All right. So the table wants you to plug in a theta of 0 and then pi over 4 and pi over 2, 3 pi over 4, and pi, 5 pi over 4, 3 pi over 2, and 7 pi over 4. All right. So since these are all in radians, we are going to want to be in radian mode if you use your calculator. So taking a look at our calculator here, we're going to plug in 3, and then that's going to be multiplied by cosine of 2 times, in this case, 0 for our first problem. So we're going to get 3 as a result, and so the first coordinate is going to be the third loop over and 0 degrees from there. Then if we do the next one, the only thing that we're going to change is this 0 here. So instead of that 0, I'm going to put pi over 4. And so notice that I did put it in parentheses because it is technically a fraction. So just saves me some mental ideas that it might not be right. And then pi over 2 is the next one. So that's -3. And then what I'm doing to get the previous entry here is the second button, which is yellow, and then the word entry, and that gets you your previous answer, so you can kind of just change it from there and not have to retype the whole thing. Either way, the next one is 3 pi over 4. And 3e to the -13 is a very odd solution for that, but that does actually mean 0 if you do this value. That means 3, but then go backwards 13 zeros. So basically 12 zeros and a 3, so 0. What happens sometimes is that the calculator gets a little bit too precise here. All right, then the next one just wants a pi in here. So we don't really need all those pieces, just 2 times pi, and we get back to 3. It turns out there is a pattern here, right? So the next one's going to be 0, and then -3, and then 0, as long as our radians have that same pattern, which they do. So we're going to go ahead and graph that. That was part A. But part B wants you to graph each of those. And so number 1, part B. So we're going to go ahead and plot 3 on our radius, so 3 circles out, and then 0 degrees from that. So our first dot is here. Then they want you to go over 0 circles and then a rotation of pi over 4, but technically that just means that will be here. So turns out, especially if you graph anything in between, and we are talking about a rose curve, that this is the start of our petal. Okay. Then the next piece is going to be -3. So -3 circles would be here, but then rotating pi over 2, which is 90 degrees. So down here. And so it does follow that the next piece kind of goes like this. Because again, we're not going to go in straight lines because we are doing polar curves. So they will kind of have this arcing distance. Then we're going back to 0. So the next point is back in the center. So we have one of our petals there. Then we want to go 3 and then pi. So 3, but then all the way over to pi. So that's this guy here. And so that means that from the center, we're going to go over here. Then it goes back to the center in 5 pi over 4, 0. Then we're going to do -3 and then essentially 270 degrees. So -3, but then 270 degrees is over here. And so from the center, we go out here. And then the next one goes back to the center. And if you continue the pattern, we're going to have this next petal. So again, kind of going to the center, down, up, left, center, up, down, back. All right. So that is your graph of that one. Then we have number 2, which is asking for r of 2 sine 3 theta. Again, another rose curve. So we're going to make our table again. They have different thetas this time. But again, we're just plugging them in. So 0, pi over 6 is going to be plugged in. Pi over 2. Sorry, pi over 3 is the next one. And then pi over 2. Then 2 pi over 3. And 5 pi over 6. And then theta. Theta, pi. And again, we're going to be in radian mode. Otherwise, we're going to get some wacky answers. Okay. So plugging in 0 for this one, we're going to have 2 times the sine of 3 times 0, or 0. So 0, 0 is our first coordinate. Then we want to put in pi over 6. So 3 times pi over 6 instead of 0. So 2 is our next value. Then we're going to plug in pi over 3. So change that 6 into a 3. And we get back to 0. Then we change it into pi over 2. And we get -2. And we are going to get a pattern as we did before. So then we'll have 0, and then back to +2, and then 0 again. And then if we had the next one, it'd be -2. So that was part A, filling in that table. Part B is going to be graphing from what we have now. So number 2B says that we're going to start at 0, 0. So here's our dot. Then we're going to go over 2 circle units, and then a rotation of pi over 6. So that's right here. And so that means that our first petal is kind of shaped that way. Then we have 0 pi over 3. So again, back to 0. And then -2, 90 degrees. So down here. Then back to 0. Then we're going to go 2 and 5 pi over 6. So that's right here. And so from the center, we go out to that guy. And then the next one is back to 0 again. All righty. So that's your 3 petal rows there. So just a reference to what happened here. anytime that you have an even number inside of a rose curve, so even number inside your petals is that number times 2. So notice that it had a 2 here, and if we multiply 2 by 2, we get 4 petals. What happens is if you have a odd number inside of your sine or your cosine, your petals are the number itself. So there's a 3 here, 3 petals. If there was a 5 here, there'd be 5. But if there was a 4 here, there'd be 8 for this one. So that's the idea, is that the petals times 2 happens with an even number, but the petals equal the number if it's odd. All right. Then we move on to number 3. And number 3 through 6, it says here in the book, we're going to draw the graph of the rose curve and state the smallest interval that will produce a complete graph. I'm not going to use this table method anymore. Now that we kind of get the idea, same rose curve, we're going to use our calculator for these ones. So the next thing here is saying state the smallest interval on which the complete graph happens. So not all of these, for instance, need 0 to pi. Or 0 to basically 2 pi. So it doesn't always need an entire rotation of the unit circle in order to make the entire graph. So in that case, we're going to see what interval between 0 and something will actually produce this graph. So number 3, we're looking at r equals 3 sine of 3 theta. And so if we want to graph this, remember that you need to be in polar mode. And in this case, we're in radian mode. So if we look at any of the angles or any of the inputs, we're going to have that. So it turns out I have 3 sine 5. So we'll just change that to a 3. So 3 sine 3 theta. And if we go to our window first, notice that since I'm in radian mode, I don't want to have in my window 0 to 360, because 360 radians is much different than 360 degrees. So let's change that to radians of 360, which means 2 pi. And then it says the step is going to be 7.5, but the idea is that you do want that to actually be a pretty small number in order to get each of the, otherwise it's going to look pixelated, so we don't really want that. So I'm just going to choose a small value there. And then it looks like I have -5 to 5, and notice that there's this 3 out here, and that actually means that the maximum on any of them is going to be 3 anyway. So just to be able to encompass everything, we'll put some 4s there as our view. And so if we take a look at this, we are getting a 3, because we knew that, 3 petaled rows. And notice that as it did this entire system of 2 pi, it did end. Okay, so what we want to do after that is see if it started to repeat or not, because you can't really tell on this calculator. So we're going to go back to our window and maybe reduce this from 2 pi. So we might go to 3 pi over 2 and see if it stops or not. Yep, so notice that 3 pi over 2 is still continued, and it's continuing to draw there for a while. So we could go, rather than 3 pi over 2, which is 3/4 of the way, we could go to pi and see if it stops there. So notice it's working, and it turns out it stops working right exactly as it ends. So we'll just double check by going to halfway between pi over 2 and pi, so 3 pi over 4. So if we go a little bit less than halfway pi. So notice that it stopped. It didn't quite complete the visual here. And so in that case, we do know that it's somewhere between 3 pi over 4 and pi, and it turns out it's actually pi. So if we continue with ending at pi for our theta, we will get the whole graph. So translating that over to our answer, we've got an image here. And it's going to be over here and kind of over here and over here. That was a poor drawing of this petal here. All right. And then we're going to say that our interval for completion there is between 0 and pi. And we're talking about the theta being between there. So that's our interval, and pretty much that's what they wanted, but of course we do have our visual of what happened. So then we have number 4, which is going to take a look at -3 cosine of 3 theta. And so kind of thinking of what's happening, this negative is just going to mean in what direction it starts drawing it. But this 3, again, means that there's going to be 3 petals. And so we just need to see what our range of being able to complete that is. So I wrote this wrong, so there you go. -3 cosine 2 theta. So we will have 4 petals instead now. So going into our y equals, we'll insert a negative and change sine to cosine, and that is a 2. All right, so going back to our graph, let's see if we still go to pi, if it finishes it. And then again, this 3 means that 4 is going to be 1 more than most of the heights here. So if we graph, again, this is going to pi. We know there's going to be 4 petals. So, oh, okay. So only halfway, it looks like, has happened on pi. So I still need this piece, this one, and that one. And so if I think that it's going to pi, we'll try 2 pi for the ending of that. So again, still working. And still working. And stopping. So it stopped right when it stopped here. But we can, of course, do a little bit less in our window than 2 pi. So we could go to, for instance, 11 pi over 6, which is that step right before 2 pi, and see if it does, in fact, finish it, because you never know. All right, and so notice that it doesn't quite finish it, and so we do need all the way to 2 pi in order to get the full effect. So in that case, we can draw our picture. With our loop across the y-axis and across the x-axis, and then our interval is again going to be between 0 but now 2 pi, and we want all the thetas between that. All right, moving on to number 5. Number 5 is r equals cosine 2 theta, 3 cosine. All right, so very much similar to this one, only the difference is going to be kind of the direction that it draws it. So if you remember this one, as it was graphed, let's see, I started here and did our loop. So it went down. So we will try to take out that negative and see what happens now. So now it's starting over here. Instead of negative, it's starting positive. And then it's going to loop the whole way around. And we did keep it as 2 pi here. So, and again, it stops right as it stops. So it's not going to continue to redraw. So in that case, we can redraw the same image, making our petals. And then our interval is going to be the same. Went from 0 to 2 pi. And we were talking about all of the thetas between that. All right, the last one is going to be r equals 3 sine 5 theta. And again, this is an odd number, so that means that we're going to have an odd number of petals. So we'll have 5 petals in our image when we're making it. And so keeping the same interval here, may as well, we're going to type in our 3 sine of 5 theta. So again, 5 petals because of the 5 inside of the sine. And then notice it's still working here, and you can actually see it kind of redrawing. So definitely 2 pi is not where it starts or stops on the interval. So we're not going to put 2 pi here. We're going to see if maybe pi works. So we're going halfway. So we'll see if we can get 5 petals going. And notice that it stopped working right when it hit here. So we should try a little bit less than pi. So maybe 5 pi over 6. Just to double check that it does actually stop at pi. Okay, and so you can see that it doesn't quite finish there if it's not at pi. So changing it back to pi so we can draw it. So our image here goes officially here, but then a little bit here. And that is my super awesome drawing. Okay, and so again, this goes to pi. Okay, then our next problems are asking, let's see here, in exercise 7 and 8, we're going to refer to curves A and B. So we've got this 8 pointed rows here and then a 6 petal rows here. And so when we look at what's happening for number 7, the graphs of which equations are shown. And so even just looking at what we talked about with the petal numbers, remember that if it's even, that means that that amount of petals is up there. And so if it's even, that means that that amount of petals is shown. So notice that there's 6 here and there's 6 petals here. This one is trying to trick you that this one, sorry, I'm saying it wrong. Anyway, they all have 3, and so notice that each of them kind of peaks out at the 3 there. The 6, remember, an even value should double to make these images here. And so in that case, there should be 12 petals if we're going to use that one. Or in this one, there should be 16 petals. And so it kind of looks like we're looking at this one here. But of course, we can always just graph to see which one is on there. So in number 7, if we take the time to graph our 1 and then our 2, and I guess we could write what they are, and then our 3, we can find out if any of them represent A or B. So R1 was going to be 3 cosine 6. And so we can type that one in here. R2 is going to be 3 sine of 8. And our 3 was 3 absolute values of cosine of 3 theta. All right, so typing in 3 sine 8 theta. And then 3 times the absolute values under your math key, under number, and it's ABS. So 3 times the absolute value of cosine of 3 theta. And so the first one graphed. That is very confusing. All right, so let's just try one of them. If you turn off these equal signs, it'll only graph the first one. So the first one has 6 petals, and oh, it didn't. Yeah, it didn't. I don't think it finished. So we'll change our window to 2 pi. Ooh, that's a lot of petals. Okay, so we've got this one and this one, and then 2 more between. Whoop. All right, so anyway, we've got 12 petals on that guy, and of course none of A or B were that option, so it's not A and it's not B. All right, then if we graph the next one, so turn off that one that we just graphed and turn on this one by highlighting the equals. Again, as we predicted, 8 theta is going to have 16 petals, and I just am not going to draw that. So 16 petals means it's not A or B. I don't know why I circled that one. And so it must be this one. And so when we graph that one, notice that the reason that we were not choosing it at the beginning is because it has a 3. And neither of the options in part A and B here have 3. And so we figured that wasn't going to be either of them. However, with this absolute value, it does change what's happening here. So notice that it's drawing that upper part and then drawing the lower part because of the absolute value. And so we end up with the image that has 1 here and here and here. And so taking a look at our options, that's this guy here, so part B. So number 7, our 3 is graphed, and it's graphed as the image of B. All right, then we have number 8, which also references these images. And in number 8, it says, we're going to use trig identities to explain which of these curves is the graph of R6 cosine 2 theta sine 2 theta. So, of course, we could just graph that and figure out which one it is, but it does say use trig identities. So we are going to try to rewrite this with some trig identities, going back to chapter 5 when we did trig proofs. So we are given that R equals 6 cosine of 2 theta sine of 2 theta. And I've done this multiple ways before, but we're noticing here at least that when we're trying to get the formulas of these, we're going to try to get a 6 or an 8 kind of happening here for those petals. But I'm also noticing that as I look at this, it's very close to What is my identity? It's my Chapter 5 formula sheet here. It's very close to this one. So notice that we have sine of 2u cosine of u, and we have 6 with a 2u, and so it kind of starts to look like some of these. I did take the time to try to do, and I did it, but it took a lot longer to do the sum and difference identities. So I changed it to cosine of theta plus theta because that's 2 theta. But a little bit more of a direct route is going to be to take, to factor out a 6. Sorry, not a 6. To change this 6 into a 2. So I am trying to reference this idea. So I want to change this 6 that we have into a 2. So I'm going to divide everything by 3 to kind of pull that out front. So we've got a 3 out front, and then we're left with 2, still cosine 2 theta, sine 2 theta. So all I did was change this number out front, kind of, because it's a 2 now, but there's still a 3. Then what I'm going to do to make it look more like what's happening here is I just want one variable inside here. So in that case, I'm going to let 2 theta equal x. So if I rewrite this so that I have every time there's a 2 theta, an x instead, I can see that it very much references this formula here. And so I can say that this thing that I just got in these box brackets is actually sine of 2x. So this entire thing is going to be sine of 2x. And that's by your double angle identity. Now, of course, we didn't have an x to begin with. We had a theta. And so now I can replace this x with my 2 theta. So 3 sine of 2, but instead of an x, I'm going to have 2 theta. But then, of course, I can change what this is because 2 times 2 theta is actually a little bit different. And so we have a 3 sine of 4 theta. And, of course, we don't really need those brackets anymore. So 3 sine of 4 theta. And so taking a look at 3 sine of 4 theta, remember that these were our options. And if it's 3 sine of 4 theta, that means that there's going to be 8 petals. So we're having 8 petals from 4 times 2. And so that means option A. And so option A is either the graph of r equals 6 cosine 2 theta sine 2 theta, or 3 sine of 4 theta. And just to confirm our images, we can go back and graph them. So if we graph 6 cosine 2 theta sine 2 theta, and then we graph 3 sine 4 theta, and maybe make this one, actually, well, just to help ourselves out, I'm going to make that one thick and this one dotted here. All right. So the first one that we're going to see is the original equation that we were supposed to then rewrite. So you can see that it's kind of following this pattern here to make 8 petals. And then the next one is what we simplified it to be. So notice that it's tracing all of the dotted points that we had. And that image, as it's finishing, hopefully represents part A right there. So there we go. All right, so kind of box that idea. All right, so that's number 8. Moving on to number 9, 10, and 11, and 12. They all have these same directions. So taking a look here, we're going to match the equation with its graph without using your graphing calculator. So we do kind of have to reference a few things about these heart-shaped or kidney-shaped limacon graphs. So few things that I want to reference when it comes to we're trying to figure out if one of the graphs is 2 plus 2 sine of theta or 2 minus 2 cosine theta. So a few things that I kind of added to our notes from before. Anytime that you are looking at this equation with a cosine, you have y-intercepts of 0, negative a, this value up here, and 0a. So taking a look at this one, for instance, we should have intercepts at, again, our a value is the one out front. We should have them at 0, 2, or negative 2, and then 0, 2. Versus if we have a sine, we should have x-intercepts of that a value. So this one is saying that it's actually at 2, 0, or negative 2, 0. So it turns out that all of the options on here have those as intercepts. So it's not really going to differentiate which one is the answer yet. So that doesn't help. The next piece that happens with sine and cosine is that if you have a negative b cosine, you're going to have a beam that's this way, and a positive b cosine is going to have a beam that's shaped that way. And so if we look at all of our options, this one here then is going to be a, here's the notes, this one here is going to be a positive b cosine, and this one is your negative b cosine. So taking a look at what we have here, negative b cosine, 2 cosine. So this one would have been the negative one, and this one is the positive one, and we have a negative cosine. So we're trying to see if option B could work for this one. For sine, if it is right side up, like a heart kind of, or upside down. Right side up is a negative sign, which we don't have. So we're looking for someone that's upside down in order to be the option. And notice that there are no upside down hearts. There's only these right side up type hearts and then the sideways ones. And so in that case, that's when we start realizing that there is not a shape like this. And so because of that, our 2 plus 2 sine theta is not going to be pictured. So that one is not going to be within there. And then, so that means that we have to pick out which one this is. And we did just say that the only one that looks like it is B. And so in that case, B is going to be the one. The other piece that we could have used is that if there is a smaller b value, like later on a 1.5, you're going to have less of a heart shape, like these kind. But the more that you have of a b value, so like a 2 or a 3 or a 4, you're going to have more of this inner loop or this concaveness. So we will go over that in a minute as well. So, sorry. So the next piece is number 10. And And in number 10, we are given the option of having the equation r equals 2 plus 3 cosine of theta, or r equals 2 minus 3 cosine of theta. And as I just mentioned, there's kind of a few things going on here, but notice that we have a positive or a negative. And so we still have this option of all of the intercepts being 2 or negative 2, so that's not really going to change, but this part changes. So a positive cosine, if you remember back to the notes we just talked about, positive cosine means that it's going to be kind of shaped where it's going to the left there, versus a negative cosine is going to be shaped where it's kind of going to the right with its heart. So if we look at our options, again, that means that we have one of these two going on. So this one could be this first one, or this one could be that one. But remember that we just said that b was actually 2 minus 2 cosine. So it can't be b for this one. It actually has to be this one, c. And remember that this number here being larger meant that it did actually have this kind of inner loop there. And so that's why C was our option. So number 10 is C. Then moving on to number 11. And again, you can do this by just graphing them as well on your graphing calculator, or graphing them by hand, since it says not to do a graphing calculator. So you could make a table like we did in number 1 and 2. In number 11, the equations that we're looking at are r equals 2 minus 2 sine theta, and r equals 2 plus 2 cosine theta. Just want to double check that I wrote those down right. 2 minus 2 sine and 2 plus 2 cosine. Okay. So again, looking at our options, of negative 2 sine. So negative sine means that we're going to have that kind of shape of a heart. Versus the positive cosine means that we're going to have this left-facing kidney bean thing. Okay. And so when we look at our options, remember that B and C are already taken care of. So B and C already have options, and so we are looking at the fact that it's not going to be this one, because none of them other than C, which we've already said is this graph, have this shape. So then we're looking at either A or D, and so now we need to figure out which one is which. They both have 2, so they both have intercepts at negative 2, 0, and 2, 0, so that's not going to help. And so the only other option is going to be this value of 2. And so remember that this value of 2 in negative 2 sine, 2 says that it's more concave than if it was less concave. Less concave is going to be pretty much, when we look at each of these, this is a 2 and this is a 2 for that number that's out front of the sine or cosine. But this one's more like, well, in the next example, a 1.5 versus this one's a 3. So notice that it does concave a lot more when it's a larger number than 2, and then it barely concaves when it's something less than 2. So in this case, 2 says it's more concave, and so in that case, we're going to go with A, because A is more concave. All right, then our last two in number 12, as I was starting to reference, and of course, process of elimination says that it's going to be D, because we have A, B, and C already. But number 12 has an R equals 2 plus 1.5 cosine of theta. And then the other R equation is 2 minus 1.5 sine of theta. And so when we take a look at this, again, cosine, a positive cosine is going to have a shape like this guy, as we just had up above. And a negative sine is going to have a heart shape. And so again, that's going to determine that it's either this one or this one, A or B. And remember that it's not going to be A because we just determined that, but we also know that it's less concave because of this 1.5 that's here. So in that case, we're going to go with D as our option rather than A. So again, because of the negative 1.5, the 1.5 part of that, 1.5 says it's less concave. And so that's why we're going with D. Alrighty, and again, if you didn't get those ones, you can also just graph them. All right, so then our next problem is number 63. And so in number 63, we are given a multiple choice question here. 65, there it is. So which of the following gives the number of petals of the rose curve? And so notice that, again, that number inside the petals says that it's times 2 to give you the amount of petals. So this image is going to have 4 petals. So our option is D. So 2 theta says 4 petals. And so our option is 4, which is D. Alrighty. Then we have number 64. And so taking a look at number 64, it says, which of the following describes the symmetry of the rose graph? And so, of course, you can just actually graph this. So R equals 3 cosine 2 theta. And so again, 2 theta says that there's going to be 4 petals in this one as well. So taking a look at our graph. Oops, deleted instead of cleared. Okay, so 3 cosine 2 theta. So we're looking at what kind of symmetry we get. And so our options are, it's symmetric about the y-axis, it's also symmetric about the x-axis, and it rotates. Especially if we change our window to be a square window, it's easier to actually see that this is symmetric and that it would be able to rotate exactly onto the other one. So if we do a square window, again, it forces this rectangle into focusing more on this square here. And so you can see that these are all exactly the same shape. And so it would rotate onto the next piece. And so in that case, we have symmetry on the x-axis, the y-axis, and the origin. And so in that case, we're going to go with option D, because that one has all 3 of them as well. All right, and then our last problem, number 66, has a multiple choice as well, and it says, which of the following is the number of petals of the rose curve? And so again, taking a look at this one, our rose curve with a 3 inside means that it's 3. So notice that they put the option of 6 there because they wanted you to pretend to double it like we would have up here with the 2, but we have a 3. So in that case, we have 3 petals, but of course you could also just graph it. So the idea is that we have R5 sine of 3 theta, and the fact that 3 theta indicates 3 petals. And so that means that we're going to go with option B. All right, so hopefully that helped you out with figuring that out. And again, a lot of this is patterns that you can find if you just go ahead and play around with these equations. So that's your 6-5 pre-calc assignment.